In this video, we will focus on values that are of the numerical data types. There are many numerical data types to choose from. We will discuss which option to use when and how to make that decision easy. We will also look at how to validate whether a value is numerical or not and how to perform operations such as addition in VBA. There are a variety of numerical data types available within VBA. There are 6 listed here from byte to decimal. However, the variant data type can also hold numbers. Now, this is just a list of commonly used numerical data types. There are even more, but we will restrict today's video to this list in front of us. And as you can see, it might get overwhelming trying to choose the right data type for a variable that needs to hold a number. The difference in each numerical data type boils down to 3 questions. What range of numbers that a data type can hold? For example, a byte can hold numbers from 0 to 255. Whether we want floating point numbers or whole numbers. Floating point numbers have a decimal point. Only double, decimal, currency, and variance can hold decimals. How much memory will a variable with a certain data type consume? For example, a variant with a number uses up the most memory with 16 bytes. Let's address the memory question first. Is conserving memory really that important? The answer is yes and no. For example, when working with large data sets, it definitely is. When working with smaller data sets, not so much. Consuming too much computer resources will lead to problems such as out-of-memory errors, Excel hanging, or even Excel crashing. Hence, as a VBA programmer, we have a responsibility to be mindful of how our code affects memory. An example being choosing the right data type. But at the same time, we shouldn't get too hung up on it either. So, for the question of memory, the suggestion would be to avoid using variants unless necessary. But besides that, the choice really boils down to whether you want to store decimals or not. If you want to store decimal places, the data type to go for would be double. If you don't want to store decimals, the data type I normally go for is long. Notice, here I'm mentioning that long is the data type I would choose. And the choice is a personal reasoning driven mostly by the convenience factor of not thinking too much about it. Long can store a large range of values from -2 billion whole numbers to +2 billion. Our largest requirement for a numerical variable is usually to store the number of rows in a dataset so that we can loop over it. The long data type satisfies this requirement since it can store a number larger than the maximum number of rows possible within Excel. The other common options for whole numbers are byte and integers, but their upper and lower limits might sometimes be restrictive. If you intend to store a flat type value where the value will be 1 or 0, then I suppose you could use a byte. But other than that, I don't think about these limits too much and just go with long unless the macro speed is noticeably slow, which is rarely due to the choice of byte versus integer versus long. The counter argument though is if your code is going to be reviewed by others. In that case, you might want to be more precise in choosing the correct data type, as it's now a question of showcasing your skill and understanding of VBA programming. But we won't judge too harshly, in this course at least. Now I mentioned earlier that we should go with a double data type when storing decimals. A double can store a floating point or a decimal number with up to 14 decimal places. A decimal data type, on the other hand, can store a higher precision with up to 28 decimals. So the question is, why use a double? The reason is that we can't declare a variable directly as a decimal, as it's a subtype of the variant data type. So there are a few extra steps involved with using a decimal data type. As we can see in this code, for using a decimal type, we need to first declare the variable as a variant and then convert it to a decimal type using the type conversion function for decimals. On the other hand, we can use a double directly. If we require a higher precision than the 14 decimal places of a double data type, then we could go with a decimal type. Let's say we want to clean the following data set. Any non-numeric values need to be converted to 0. How do we do that? We can use the isNumeric function to check whether the value within the cell can be converted to a number or not. Here we have a piece of code that loops over the data set. The last row is the count of rows in the data set, and we are going to loop over every cell from the second to the last row and check whether the value in that cell is numeric or not. Our logic is going to go within this for loop. So if isNumeric, and what are we checking to be numeric? We are checking the value in the current cell. Don't worry about the syntax if you're following along in the course. We will cover it soon in the video on loops. Just know that this cell represents the current cell that we are looping over. The isNumeric function will return true if the value can be converted to a number and false if not. So if the function returns a false, then we'll change the value of the current cell to 0. Okay, let's have a look at a data set once again. We have two non-numeric values in rows 4 and 6. Run this code, check Excel, and the text values have converted to 0. So our code works. However, there is one issue out here. Suppose we have a blank cell out here. Let's see what happens when we run our code. Go back to Excel. The blank cell remains as is, but we want to change it to 0 as well. What happened here is that the isNumeric function doesn't check whether the value is a number or not. It checks whether the value can be converted to a number. An empty cell has the value of an empty string which can be converted to a 0. Hence, our function ignores it. There are a few ways around this problem. We can test for both conditions, that is, if the cell is numeric or if the cell is empty. We can use the OR operator to add two conditions. To test for the blank cell, we will use the isEmpty function. And now, if the cell is empty, that is, if the isEmpty function returns a true, then we will change the value to 0. So basically, if the cell is not numeric or it is empty, then we will change the value to 0. Let's run the code, go back to Excel, and it works. If we want just one condition to address both issues, then we can use the Excel isNumber function. The isNumber function checks whether the value is actually a number or not. And Excel functions in VBA are available as methods of the worksheet function object. So let's remove the isEmpty condition and call the isNumber function. There it is. Okay, let's check a data set first. We have a text value and a blank value. Run the code. Both values are changed to 0. Just like in Excel, we can perform actions such as addition, subtraction, etc. in VBA using arithmetic operators. We have a list of arithmetic operators available to us on the screen here. So let's print 3 times 2 using the asterisk symbol, which is the operator for multiplication. Run the code. Answer is 6 as expected. But what is the result of this next expression? Is it 3 plus 3, that is 6, times 2, which gives 12? Or is it 3 times 2, which is 6, plus 3, which gives 9? Let's test it out. We get 9. There is a certain rule at play here called Order Precedence. We can see the arithmetic operators listed on the screen by the order of their precedence. And we can see that multiplication is ranked higher than addition. This means that in a given arithmetic expression, such as the one in our code, a multiplication operation will get actioned upon prior to any addition operation. But do we need to memorize this precedence order? We can, but it's not necessary. What we need to know is that there exists an order to performing multiple arithmetic operations in a single expression. However, we don't really need to know what the order itself is. That is because we can use a parenthesis or a round bracket which overrides every order of precedence. Let's look at an example again. Suppose that when we were constructing this expression, what we really wanted to perform is the addition first, followed by the multiplication of the output of the addition, giving a result of 12. We can force the result by adding parentheses around this sub-expression. Now, the logic within the parentheses will get evaluated first, regardless of order precedence. Run the macro, we get 12. Now suppose we want to divide the result by 3 to give 4. We don't even need to look at the order precedence table to see the rank of the division operation. Let's wrap the initial output within parentheses and divide that result by 3. Run the macro, we get 4. We learned about how to choose between numerical data types. My suggestion is to use long for whole numbers, use double for floating point or decimal values, and don't use variant unless the value is truly unknown. The isNumeric function can check whether a value can be converted to a number or not. For blank values, use isEmpty. There is an order in which arithmetic operations are performed within a VBA expression. Use parentheses to override that order and control the final output. In the next video, we will deep dive into ways of working with the Boolean data type.